Hello everybody. In this video I will solve one problem related with the one constraint, okay, Lagrange multipliers with one constraint function, and one problem and the summary of the theoretical part of the two constraints part of the Lagrange multipliers. So let's solve first of all this problem, and here we want to find the points on the sphere x squared plus y squared plus z squared equals 4 that are closest, okay, closest and the farthest, closest to and farthest from the point 3, 1 and minus 1. We have a point on space 3, 1 and minus 1, and we are looking for the points on the sphere which is closest to that point and farthest from that point. Okay, so we are looking for the distance actually in this problem. So we just want to maximize and minimize of the distance between this point and a point on the sphere. Okay, so and a point on the sphere. So first of all, let's remember the distance formula. Distance from a point x, y, z to the point 3, 1 and minus 1 is b in the square root difference of the first components plus difference of the second component plus and the difference of the third components. Okay, but the algebra is simpler if we instead maximize and minimize the square of this distance. Okay, so to make calculations easier, we deal with the square of this distance. Okay, so now I can write the results. The function to be optimized is f of x, y, z. Sorry, there should be z here. X minus 3 squared plus y minus 1 squared plus z plus 1 squared. And the constraint function here, this, because we just want to that point should be on this sphere. Okay, g of x, y, z equals x squared plus y squared plus z squared equals 4. Okay, so according to the method of Lagrange multipliers, we should solve the following equations. Gradient f should be equal to lambda times gradient g, and g of x, y, z equals x squared plus y squared plus z squared is 4. We should solve these equations. So from here what we have? Gradient f is f sub x, f sub y, f sub z equals lambda times g sub x, g sub y, and g sub z. So f is here, this is our f, okay? And from here I have 2x minus 3 and 2y minus 1 and 2z plus 1. And from here I have lambda times, and the partial derivatives are 2x, 2y, and 2z. Okay, so we have this equation. 2x minus 3, 2y minus 1, 2z plus 1 equals 2x lambda, 2y lambda, and 2z lambda. Okay, so let's write the equations to be solved here. I have the following equations now. I have 2x minus 3 equals 2x lambda, and 2y minus 1 equals 2y lambda, and 2z plus 1 equals 2z lambda, and x squared plus y squared plus z squared equals 4 from the constraint. So this is first equation, this is second one, this is third one, and this is the fourth one. Okay, we have 4 different equations here. And first of all, I will try to solve first equation separately, because in the first, third, and second and third equations, we have only x and lambda, right? So there is no relation between 1, 2, and 3. So using first 2 and 3 equations separately, solving them separately, we can write x, y, and z in terms of lambda. Then we can substitute these results in the fourth equation, and we can obtain lambda here. Then using the formulas obtained for x, y, and z, and the result for lambda, by substitution we can obtain x, y, and z at the end. So let's start with this solving first equation. Okay. If you look at the first equation here, first of all, I can cancel 2's, right? So I have x minus 3 equals x lambda. So we have x minus x lambda equals 3. And in the common parentheses of x, I have x times 1 minus lambda equals 3. So at the end, x equals 3 over 1 minus lambda. Okay, so we should be aware of this. Lambda cannot be equal to 1. Because of that, this denominator cannot be equal to 0. Why? If lambda is 1, okay, here, note that lambda is not 1, since if lambda equals 1, if you look at the first equation, you have x minus 3 equals x, which means 0 equals 3, and this is contradiction. Okay, this cannot be happen. So because of that, lambda is not 1, so we can easily divide each side with by the 1 minus lambda. So this is the formula for x. Okay, let's look at the second equation. I have, again, I can cancel 2's here. Y minus 1 is y lambda. So y minus y lambda equals 1. So I can take the common parentheses of y. And because, again, lambda is different from 1, y is 1 over 1 minus lambda. Okay. So let's try to solve the third equation for z. I will cancel 2's. Z plus 1 equals z lambda, and here z minus z lambda equals minus 1. So z times 1 minus lambda equals minus 1, and I have z equals minus 1 over 1 minus lambda. Okay, so I know what is x, what is y, and what is z in terms of lambda. It means I can substitute each of them here in the fourth equation, in this equation, to find what is lambda. Okay, because if I know what is lambda, I can find x, y, and z. So substitute in 4. X squared is 3 squared over 1 minus lambda squared plus y squared is 1 squared over 1 minus lambda squared plus minus 1 squared over 1 minus lambda squared should be 4. From here I have 9 plus 1 plus 1, which means I have 11 over 1 minus lambda squared is 4. So it means I have 1 minus lambda squared is 11 over 4. So at the end, 1 minus lambda equals minus square root of 11 over 2, or 1 minus lambda equals square root of 11 over 2. So I have the values for lambda as lambda equals 1 plus square root of 11 over 2. From here I just take this to this side and this to this side, or lambda equals 1 minus square root of 11 over 2. We have two different values for lambda. Depending on this, we will obtain different values to different points here. Okay, let's calculate x, y, and z using these lambdas. Okay, if lambda equals 1 plus square root of 11 over 2, then we know that x is 3 over 1 minus lambda, so I have 3 over 1 minus square root of 11 over 2 plus 1. So I have 3 over minus square root of 11 over 2, and which means minus 6 over square root of 11. Okay. Then y is here 1 over 1 minus lambda. So I have 1 over 1 minus 1 plus square root of 11 over 2, which means minus 1 over square root of 11 over 2. I have minus 2 over square root of 11. And z is minus 1 over minus 1, 1 over minus 1 lambda, which is minus y actually. So I have plus 2 square root of 11. If you multiply this with minus, you will obtain plus 2 over square root of 11. So the first point is minus 6 over square root of 11, minus 2 over square root of 11, and 2 over square root of 11. Okay. So what if lambda equals 1 minus square root of 11 over 2? Then x is 3 over 1 minus lambda, which means I have 3 over 1 minus square root of 11 over 2. So it means 3 over square root of 11 over 2 I have. So I have 6 over square root of 11. And y will be equal to 1 over 1 minus lambda. So I have 1 over 1 minus square root of 11 over 2. I have 1 over square root of 11 over 2 because 1 and 1 will be cancelled. So 2 over square root of 11 we have. And we know that z is minus y. So we have minus 2 over square root of 11 as z. So the second point is, square root of 11, 6 over square root of 11, 2 over square root of 11, and minus 2 over square root of 11. So we have two different points. So to find the minimum and the maximum distance, we should substitute these points in this function, in the distance function. And the distance function was that f of xy is x minus 3 squared plus y minus 1 squared plus z plus 1 squared. So f of first point minus 6 over square root of 11, 2n plus 2. If you substitute this first point in the function, then you will obtain minus 6 over square root of 11 minus 3 squared plus minus 2 over square root of 11 minus 1 squared plus 2 over square root of 11 plus 1 squared. Okay, because we have square function, this minus and this minus will be plus, right? I can rewrite this term because like that, minus 1 times square root of 11 plus 3 squared. So derivative is square of this term will be 1. So I have 6 over square root of 11 plus 3 squared plus this part will be 2 over square root of 11 plus 1. So I have one more than 2 times 2 over square root of 11 plus 1 squared. You don't have to calculate this result. It's enough to compare it with the value of the function at the second point, which is square root of 11, 6 over square root of 11, 2 over square root of 11, and minus 2 over square root of 11. Let's substitute it in the function again. I have first component minus 3 squared plus 2 over square root of 11 minus 1 squared plus minus 2 over square root of 11 plus 1 squared. Okay, so as you can see, this is just a multiplication of this with minus 1. So I can rewrite 2 over square root of 11 minus 1 as minus 1 times 1 minus square root of 2 over 11. Okay, so this part will be 2, so it is equal to that function. So I have this 6 over square root of 11 minus 3 squared plus 2 over square root of 11 minus 1 squared times 2. So if you compare this value and this value, you can see that this is greater than that one, because I have this plus this, they are both positive, and here we have difference. So this number is greater than that one, and this number is also greater than that one. So squares of these numbers are greater than squares of that numbers. Because of that, the value of this function at that point is greater than that point. So as a result, I can say that if I say this b and this a, b is greater than a here. Okay, so because b is greater than a, this is the smallest value, which means this is the smallest distance, so it is the closest point here. Okay, so the closest point is that point, and the farthest point is that point. Why? Because if it is greater than that one, this means this distance is greater than that distance. So this point is farthest from that point to the given point, 3, 1, minus 1. Okay, so it is minus 6 over square root of 11 minus 2 over square root of 11 and 2 over square root of 11. So this is the closest point on the sphere, and this is the farthest point on the sphere from the given point. What was it? It is 3, 1, minus 1. Okay. So let's talk about two constraints here. For this time, suppose we want to find the maximum and the minimum values of a function f of x, y, z, subject to the constraints of the form g1 x, y, z equals k1 and g2 x, y, z equals k2. So we have two constraint function here, and we have just one function to be optimized. Okay, then for this time, again, we will use same steps, but we should solve the following equation. Gradient f of x0, y0, z0 should be equal to lambda 1 times gradient of g1 at the point plus lambda 2 times gradient of g2 at that point. I have gradient here. Okay, we should solve this equation for this time. So in this case, Lagrange's method is for extreme values by solving 5 equations in 5 unknowns, because from here we have 3 different equations, but we have 2 constraints, so we will obtain 5 different equations. And these equations are obtained by writing this equation, this first equation here, this one, in terms of its components and using the constraint equations here. So we should solve the following equations. First of all, gradient of f at x0, y0 will be, first component is f sub x, and from here we have lambda 1 times g1 sub x plus lambda 2 times g2 sub x. This comes from the first component of this equation, equality. And the second part will be lambda 2 g2y plus, lambda 1 g1y, lambda 2 g2y, and f sub z equals lambda 1 g1z plus lambda 2 g2z, okay? And we have g1 constraint function and g2 constraint function. So we have 5 different equations and 5 unknowns, x, y, z, lambda 1 and lambda 2. And solving these 5 equations for these 5 unknowns, we can obtain the points, and then we will substitute our points in the function and we will compare the results to obtain the maximum value and the minimum value. In other words, we will do the same thing, but we will have more calculations here. The difference is only that. Okay, let's solve a problem. Okay, I want to find the maximum of the function f of x, y, z on the curve intersection of the plane x minus y plus z equals 1 and the cylinder x squared plus y squared is 1. We have two different surfaces in this space, but we have an intersection of these surfaces which is a curve, and now we just want to find the maximum value of this function on that curve. Okay, so I will write the, first of all, function to be maximized, and the function is f of x, y, z equals x plus 2y plus 3z. Okay, and the constraint functions are first of all g1 x, y, z equals x minus y plus z equals 1 and g2 x, y, z equals x squared plus y squared equals 1. Okay, first of all, let's write the Lagrange condition here. Lagrange condition is gradient of f equals lambda 1 times gradient of g1 plus lambda 2 times gradient of g2. So it means I have this f sub x, f sub y, f sub z equals lambda 1 times g1x, g1y, and g1z plus lambda 2 times g2x, g2y, and g2z. So we have this equality. F sub x is 1, f sub y is 2, f sub z is 3 equals lambda 1 times the first derivative of g1 with respect to x is 1, y is minus 1, z is 1 plus lambda 2 times, here I have 2x, 2y, 0. So let's sum these vectors. First of all, multiply and sum. Lambda 1 plus 2x lambda 2, right? Here minus lambda 1 plus 2y lambda 2 and plus, lambda 1 plus 0, which is lambda 1. So I have 1 equals that component, 2 equals that component, 3 equals that component. Also two different constraints. So as a result, the equations to solve here, equations 1 equals lambda 1 plus 2x lambda 2, 2 equals minus lambda 1 plus 2y lambda 2, 3 equals lambda 1, and x minus y plus z equals 1, x squared plus y squared is 1. Okay, we have 5 different equations here. And we will solve these equations for x, y, z, lambda 1 and lambda 2. Okay, and from 3 we can directly obtain the result for lambda 1. It's seen directly, and let me write it here. From 3, lambda 1 is 3. Okay, so I will substitute lambda 1 and 2. If I substitute lambda 1, 3 here, I will obtain 1 equals 3 plus 2x lambda 2, which means 2x lambda 2 equals minus 2. So I have x lambda 2 equals minus 1. Okay, so I can say that this x equals minus 1 over lambda 2. So let's check. Lambda 2 can be equal to 0. If lambda 2 is 0 here, then this and this term will be 0. From the first equation, lambda 1 will be 1. And from the second equation, lambda 1 will be minus 2. And in the third equation, lambda 1 is 3. So, because lambda 1 is 3, lambda 2 cannot be 0. Okay. So because of that, I can directly divide each side by lambda 2. And from the second equation, 2 equals minus 3 plus 2y lambda 2. So 2y lambda 2 equals 5. So I have y lambda 2 equals 5 over 2, which means I have y equals 5 over 2 lambda 2. So we have x and y in terms of lambda 2. Lambda 2 cannot be 0 since lambda 1 is 3. Okay. If lambda 2 is 0, then from 1, lambda 1 is equal 1, and from 2, lambda 1 equals minus 2, and this is contradiction. Okay. So, I know what is x, I know what is y in terms of lambda 2, so it's time to find z in terms of lambda 2. To do this, I will use the fourth equation. If I substitute x, y here, then I will, there is no need to use that one because I can directly use x and y in the fifth equation to obtain lambda 2. Let's do it. Substitute x and y to 5, okay, to obtain lambda 2. I have minus 1 over lambda 2 squared plus 5 over 2 lambda 2 squared equals 1. From here I have 1 over lambda 2 squared plus 25 over 4 lambda 2 squared equals 1, which means I have 29 over 4 lambda 2 squared equals 1. So lambda 2 squared equals 29 over 4, which means lambda 2 is equal to minus square root of 29 over 2, or lambda 2 equals square root of 29 over 2. We have two different possibilities. Okay, so if lambda 2 equals minus square root of 29 over 2, then x will be equal to, because of this, minus 1 over minus square root of 29 over 2. I have 2 over square root of 29, and using the same idea, y will be equal to 5 over square root of 29. And if lambda 2 equals square root of 29 over 2, then x will be equal to, using that formula, minus 2 over, oh sorry, you didn't see them. Okay, if lambda 2 equals that number, I just substitute lambda 2 here and here to obtain x and y. And if lambda 2 equals that number, for this time I just substitute again that number in this and this formula to obtain x and y. And x is minus 2 square root of 29, and y is 5 over minus 5 over square root of 29. So we know x and y, but we don't know what is z, right? So to find z here, I will use fourth equation. Okay, equation 4 here. Equation 4 is x minus y plus z equals 1. So we know what is the equation for, and we know the values of x, y here. So first of all, I will write here z in equals 1 minus x plus y, right? So it gives now I will just use these first of all. If x is 2 over square root of 29 and y is 5 over square root of 29, then z equals 1 minus 2 over square root of 29 plus 5 over square root of 29, right? So I have 1 minus, I have there is a mistake here. Yes, we did a mistake here. Here, because lambda 2 is in this part, because lambda 2 is minus square root of 29 over 2. If you substitute here, you will obtain minus 5 over square root of 9. And here, because this is positive and there is no minus here, we have plus sign here. So I will substitute them directly in the formula of z in the equation 4. I have minus sign here, so this will be minus, so 1 minus 7 over square root of 29, okay? If x is minus 2 over square root of 29 and y is 5 over square root of 29, then z will be equal to 1 plus 2 square root of 29 plus 5 over square root of 29, which is 1 plus 7 over square root of 29. Okay, so we know what is x, we know what is y, and we know what is z. So it's time to calculate our function at these points. Okay, the corresponding values of f are f of first point, and let's remember what was the f. F was here, x plus 2y. Let me write it here. F of x, y, z equals x plus 2y plus 3z. Okay, so the value of the function at that point is x plus 2y, 2 over square root of 29 minus 10 square root of 29, plus 3 minus 21 over square root of 29 equals, here 3 minus, I have 2 minus 10, which is minus 8 plus minus 21 is minus 29 over square root of 29, which is 3 minus square root of 29. And at the other point, I just substitute in the function minus 2 over square root of 29 plus 10 over square root of 29 plus 3 plus 21 over square root of 29 is 3 plus 29 over square root of 29, which is 3 plus square root of 29. So this is the maximum value and this is the minimum value. So in the problem, we want to find the maximum value, so result will be this: the maximum value of f on the given curve is 3 plus square root of 29. Okay, so this is the end of this video. See you on next video.